Today's lecture is a little bit of a review, but it should be a useful one because we use linear interpolation in engineering economics quite a lot. Linear interpolation is approximating a more complicated function by a straight line. And this allows us to develop useful relationships between dependent and independent variables. I'd like to illustrate this graphically first, and then develop a formula. Here we have a graph of a function. We have an independent variable x and a dependent variable y. And this function is a complicated one for which we can calculate the dependent variable from the independent one, but at a certain cost. So if we wanted to, we could find out all the values of this function by doing all those calculations. But by and large, we don't want to because of the difficulty in doing so. Now, I have illustrated on here the entire function, which in general we won't know without calculating individual points. And 2 points have been calculated. We could continue and calculate more points and specify this function exactly, but no matter how many points we do end up calculating, there's always a region in between the 2 points we calculate that we really don't know the shape of the function. So we're always stuck with the same problem of not knowing the function exactly. Now let's say we're given a value of the dependent variable y. We call it y prime. Not knowing the actual shape of the function between the two values of x here, x1 and x2, what would be useful would be a way of determining the value x prime associated with y prime, for which would be the appropriate corresponding value of x. And this is difficult because x is the independent variable and y is the dependent one, and our formula doesn't allow us to go backwards. The way we do this is by approximating the function between the two known values, x1 and x2, by a straight line. I'll put a straight line in here, for example. That's supposed to be straight. And then by approximating that as a straight line, we can calculate a value for x prime, which is in fact the wrong value in general, because that function will not generally be a straight line. But by and large, it'll be close enough for most purposes. Now, the advantage of doing that is that it's fairly easy to do that approximation, whereas it may be very difficult or virtually impossible to do an exact evaluation of the x prime. Now, we can use that principle and develop a formula for linear interpolation. Now, the idea behind the formula works on this idea of a straight line. What we do is we look at the proportion, the distance, if you like, proportion of the distance between y1 and y prime to the distance between y1 and y2, and compare that to the distance between x1 and x prime and the distance between x1 and x2. Since that's a straight line, those proportions are always going to be the same. If y prime were up here, x prime would be over here too. So that ratio of the distances between the desired value and the known value are going to be the same given a linear relationship between the two known points. So what we can say then is that the ratio between the distances for the dependent variable and the independent variable are the same. So that x prime minus x1 over x2 minus x1, that's the ratio for the independent variable, is going to be the same as the ratio for the dependent variable, y prime minus y1 over y2 minus y1. Simplifying this, we can take the denominator from the left-hand side and move it over to the right-hand side. And then as a final step of simplification, we can say that x prime, which is the value we want to calculate, is equal to x1 minus, that's plus, x2 minus x1 times y prime minus y1 over y2 minus y1. Now what this gives us here, this final expression, is exactly what we desire. We're looking for a formula for calculating a particular value of the independent variable given known values x1, x2, y1, and y2, and a target value for the dependent variable y prime. Now this is a very useful formula, and we'll see in later lectures how we can use this in engineering economics to simplify our calculations. Thank you.